This month, there's a majestic sight in our night skies. Mars is the closest and brightest it's been for many years.
Mars captures the imagination like no other planet. So come with us and let us take you to this amazing world. Let's journey to Mars. We're in Stevenage, where Airbus has built a small slice of Mars here on Earth to test out prototypes for Europe's ExoMars rover.
And coming up, geologist Ian Stewart will reveal how these rocks help unlock the secrets of Mars.
So this really is evidence that through here, in the past, once flowed a mighty river.
Pete Lawrence will be showing us the great things we can see on Mars from right here on Earth.
That's fantastic. There's so much detail there.
We'll be giving one of you the chance to capture your very own photograph of Mars by taking control of the most powerful camera in Martian orbit.
And away from Mars, could this be the scientific discovery of the century?
But first, our journey to Mars begins above the Red Planet. It's astonishing what discoveries have been made without even landing on the surface.
Although we're used to thinking of Mars as a dry and dusty red desert, it's actually an amazingly varied and even a dynamic place. The high-rise camera on NASA's Mars Reconnaissance Orbiter allows us to see the planet in exquisite detail. It reveals a series of extraordinary landscapes, from these vast fields of ice sculpted into varied and wonderful forms,
to shifting seas of sand dunes, their shady sides covered in frost.
There are areas covered in polygons where ice has thawed and cracked, creating these almost leaf-like structures.
And impact craters that help tell us the age of the surface of the planet.
And the high-rise camera has revealed that this dynamic world can also change, almost in front of our eyes.
This is an image of spring arriving at the polar ice caps on Mars.
Mars is tilted on its axis, just like the Earth, and so it too has seasons. What you can see here in this sort of brain-like image is the ground emerging through the ice as it begins to thaw.
But this is actually frozen water and frozen carbon dioxide, otherwise known as dry ice.
Mars's atmosphere is so thin that it can't sustain liquid water on its surface in most circumstances. But have a look at these images from near the Martian equator. There seems to be something flowing down this slope.
Now this is quite controversial because there's debate as to what it is. Some people think water, and some people think it's salt water, which is actually fluid at a much lower temperature.
Other people think it's just carbon dioxide or maybe some dust rolling down the slope. If not though, this could be the first images to show liquid moving on the Martian surface.
Now the Martian atmosphere might be incredibly thin, but it doesn't mean there's no weather there, as we can see in this image. This spiral is a dust devil half a mile high, a huge tornado in the Martian atmosphere.
Now this is one of my favourite images. This is a uniquely Martian scene. This is the result of blocks of dry ice skidding down a slope, almost as if they were skiing.
Now we use dry ice here on Earth at room temperature to create a nice atmospheric smoky scenes. But on Mars, the atmosphere is at minus 150 degrees C, and so the dry ice stays frozen.
So what we're seeing here is something that couldn't happen on Earth. Mars is a funny planet. Sometimes it looks so Earth-like, and sometimes it does something like this that's uniquely Martian.
A little later, we'll be giving you an exciting opportunity to take control of the high-rise camera and get your very own image of Mars.
Thanks to HiRISE and the other orbiting cameras, we've been able to explore the Mars of today. But what's really exciting is trying to understand the Mars of the past.
Today, the Red Planet is a hostile environment for life. But it now seems, over 3.5 billion years ago, it was very different. This history has been uncovered by a succession of rovers that have travelled to Mars as our surrogate explorers. In 2004, 2 rovers, Spirit and Opportunity, arrived on the planet. They were designed to survive for 90 days, but Opportunity is still going strong, 10 years later. And then in 2012, the much larger Curiosity rover arrived. In just a single decade, these missions have transformed our understanding of Mars by allowing us to read the secrets contained within its rocks. Geologist Ian Stewart has been investigating how the rocks on Mars have allowed us to search for signs of ancient water and recreate the planet's astonishing past.
Inside here is something really precious. That is a slice of another planet. This tiny rock is a bit of a meteorite which fell in Oman in the desert in 1999, but actually it's from Mars. It's one of about 130 or so meteorites that came from Mars, blasted off by asteroid impacts. The thing is, you could tell a lot about a place and its past from the rocks that it leaves behind. So this, I know, is an igneous rock. It's a basalt, which means at some point in the past, volcanoes were erupting on Mars. This little rock tells us a great deal about how Mars formed, but it doesn't help us with the really big question. Could the planet have once harboured life?
The Mars rovers are roaming the surface of the red planet, searching for rocks that reveal clues to what the environment was like in the past. Reading this evidence is a skill we've perfected here on Earth. This rock face is part of the Jurassic coastline in Devon. It was formed around 240 million years ago, and it provides a detailed record of different environmental conditions.
There's a whole set of layers in this cliff, and the thing is, if you know how to read them properly, you can kind of create these different environments. So here we've got a layer of cobbles, and there's a layer of sand coming through, and here's more of these cobbles, sand, cobbles. And then we get this here, it's more of a soil. This is an ancient land surface. And then above that, it's just sand blown around by the wind. Now these are really distinctive. You can see how beautifully rounded all those pebbles are. Look at them, incredible. So they would have started off as just general angular rocks, but what's made them all smooth is water. They've been churned around in a turbulent flow. You imagine a big river of debris coming along, knocking the edges off the clasts as they go, and just creating these beautifully smooth pebbles. So this really is evidence that through here, in the past, once flowed a mighty river.
The one key condition that most scientists agree is needed for life to have existed on Mars is water. So the rovers have been searching for rounded pebbles that might be signs of riverbeds. But just along the coast is a different kind of rock formation that shows a very different kind of evidence of contact with water, and potentially an even more favourable environment to search for life.
What we've got in front of us here is it's like just a wall of sand, just layer upon layer of sand dunes piled on top of each other. But in amongst it is these little bands here. There's another one, and they get a little bit thicker, and they look different to the sand above. In fact, if you look in here, how crumbly this is. Because what we've got here is a deposit that's been laid down by really fine sediment settling out of standing water. Essentially, this is a temporary lake among the sand.
You only get rocks with this incredibly fine-grained structure if they were formed when water becomes really still, as it is in lakes and ponds.
Just taking a big dollop of sand here, and as I swirl it round, you see that as long as I keep the swirl going, then most of the sediment is still in the water. But watch what happens if I stop the flow. Immediately, the finer sediment, the mud and the silt just settles out. So that means that whenever we see a kind of thin band of really fine sediment, we know that it must have fallen out from still water.
This kind of sediment is much more likely to preserve signs of life because it formed in a much gentler way.
Using these geological tricks, we've built up this detailed and compelling picture of the history of water on Earth. But what does all this mean for Mars?
NASA's Mars Curiosity rover has been taking close-up images of rocks on Mars and sending them back to Earth for scientists to analyse. Sanjeev Gupta is a geologist on the Curiosity team.
So this is a photograph taken by Curiosity, is that right?
That's right, this is Curiosity and Gale Crater, and you can see these beautiful gravel plains that Curiosity is driving over, searching for rock layers that might contain evidence for past life.
So what kind of rocks did it encounter then?
So here we are, we can see these beautiful rock layers here. If we zoom in, you can see that it's actually made up of lots and lots of small particles, pebbles. But what's really exciting about this rock is that the pebbles themselves are actually rounded. So we actually interpret this rock layer to be actually an ancient stream bed.
That's so cool.
And that's the first time we've had that sort of evidence. Now, rivers aren't that great for looking for ancient life. You know, you can imagine these pebbles are being tumbled in these flows, and it's just too high energy. Yeah. And what geologists really look for searching are quiet water environments, calm environments, where particles, sediment particles, can settle out of suspension and trap organic matter, for example. And, you know, the best environment would be an ancient lake. Now, we never dared expect to find an ancient lake, but this is what we saw. So here's one of the first ever drill holes on the surface of another planet.
That's extraordinary. That's something we do all the time on Earth.
That's right, we do it all the time on Earth. This is one of the first ones. And you can see this drill hole is about 2.5 centimetres in diameter. And you can see the rock powder that's resulted in the drill tailings over here. The next image is just fantastic because this is actually an angled view into the drill hole. And you can see the grains over here, very, very fine grained. This drill hole is about 2.5 centimetres
So these
across.
are smaller than sand grains?
That's smaller than sand grains. And these layers are basically built up through time in an ancient lake. And this is a perfect environment to look for clues for ancient life.
Curiosity has been able to go even further, creating the clearest picture yet of Mars over 3.5 billion years ago. Using its onboard laboratory, it's analysed these samples to show that not only did Mars have water, but that the water would have been fresh.
You know, it's amazing to think how much we've managed to learn by studying the rocks on another planet without having to actually go there ourselves. The picture it reveals is Mars over 3.5 billion years ago, awash with fresh water and primed with the ingredients to support life.
Not only that, but we now have a good idea about where to look for direct signs of past life on Mars. And that's exactly what the next rover will do.
Mars has captivated us for millennia, and one of the reasons is that as our next-door neighbour, it's an unmissable presence in our skies. And so Pete Lawrence begins this month's Star Guide with some tips on how to observe Mars.
Now is a great time to go and view magnificent Mars, and you can see it up there just off to the left of the Moon. The reason why this is such a good time to look for it is that the Earth is currently located between Mars and the Sun, and that means that Mars is at its closest to us. This occurs roughly every 2 years or so. When it happens, Mars appears bright in the sky and is really easy to find with the naked eye.
The motion of Mars across the night sky is extraordinary. It appears to wander back and forth, performing a giant loop.
And Mars isn't actually moving around the solar system in an unruly fashion, but what's happening is that we're seeing an illusion caused by the fact that the Earth is orbiting the Sun faster than Mars. As we overtake the red planet, so Mars appears to loop back on itself in the sky, an effect known as retrograde motion.
Of course, its most obvious attribute is its colour. The colour comes from the rocks on the surface of the planet, but it's not uniformly red, which means with a good telescope you can still see some splendid features on its surface. And that's exactly what the members of the Bedford Astronomical Society are doing.
Oh, this looks interesting.
Well, that's an image we captured of Mars last Friday. I was really pleased with it. We've got some nice detail showing up.
You've got that lovely V-shape feature there, which is Syrtis Major, of course. And then further to the south of Syrtis Major, you've got that bright patch there, which
It's
actually
so bright, isn't it?
looks to me like it's a polar cap, but it's not, is it?
No, it's the Hellas Basin, this huge impact feature. It's 9 kilometres deep, and it just must be full of cloud at the moment, which is why it's so white and shiny.
So bright and reflective. But that
bright patch you've got at the top there, that is a polar cap.
That's a genuine polar cap,
Yeah.
but it's decreasing all the time.
That's fantastic. There's so much detail there. Now, we've seen some fabulous images of Mars tonight, and if you manage to get any of your own, send them through and we'll put up a selection on our website. Now, Mars is an amazing object to view and observe at the moment, but there's plenty on offer around that part of the sky as well, so here's this month's star guide. Mars is currently rising in the southeast in the constellation of Virgo as darkness falls, and throughout the month tracks west. It begins close to the bright white star Spica and ends the month just south of the middle bright star Porrima. Porrima sits at the bottom of a large semicircular pattern of stars known as the Bowl of Virgo. If you have a telescope, select a low-power eyepiece and sweep through the region close to the top of the bowl. It's known as the realm of galaxies. This part of the sky is full of distant galaxies which appear like faint smudges. The region to the left of the bowl currently plays host to dwarf planet Ceres and minor planet Vesta. Vesta is currently on the verge of naked eye visibility from a dark sky sight, but both objects are well within binocular range. Finally, let's return to Mars. The most distinctive feature you can pick out with a telescope is known as the Syrtis Major, a large dark V-shaped pattern. The best time to look for it throughout April is around 11 p.m. between the 18th and the 28th.
More from Mars in a few minutes. But first, last month we showed you how to take amazing images of the night sky with a smartphone. And you've been sharing your results with us.
This image by Andrew Carter shows the Clavius crater on the Moon in fantastic detail.
Paul Newton caught Venus transiting the Sun.
And you can make out the shadow of Jupiter's moon Io in this image by Damien Weatherly.
And Michel Reitzmer managed to capture Saturn and its famous rings. Now it's time for this month's Astro News, and there's been a lot happening in the astronomical world since we were last on air.
Certainly has. For starters, the solar system has a new member, and here it is. This is 2012 VP113.
Snappy.
We'll get a better name soon. But what you can see here is images taken over 6 hours and coloured so that you can see that something's moving. And that's actually a dwarf planet in the outer solar system. Now, this thing's in a really unusual orbit, much further out than Pluto, 2.5 times as far from the Sun as Neptune is, and orbiting in a place where it's got no right to be. The only other thing around there is something called Sedna, which we found just over a decade ago. But those two things are on orbits that we can't explain using conventional solar system mechanics. So it's a very exciting time.
And another potential dwarf planet.
That's right, another dwarf planet, assuming it holds up. We don't quite know its size yet. But there have been other weird discoveries in the outer solar system as well.
And this time much closer to home. There was a collection of asteroid-like bodies that lie between Saturn and Uranus. They're called the Centaurs. And one of these, the largest of them, has actually been discovered to have rings. And this is an artist's impression of it. So that's the object, and here are the 2 rings around it. Now, this was actually discovered in about 20 seconds of data, because the asteroid was passing in front of a star, and you get a dip in the light level on occultation. Now, usually with a large object like this, you'll just get a single dip. But what happened here is they got 5, and sort of 4 little ones and 1 big one, which actually was an indication of you passing through these rings. Now, it's the first time that we've actually seen rings on a body this size. And what the mystery is why were they formed? Where did they come from? Because you just don't get them on things this size. But I think we'll be looking out for them in the future. But of course, the story dominating the news at the moment is the results from Bicep 2 in the South Pole, which, if confirmed, could lead to some Nobel Prizes.
But more importantly, it seems to be telling us about a time just a 10 million billionth of a second after the Big Bang, when something called cosmic inflation took place, with the universe expanding from a tiny subatomic particle to something much larger, setting the stage for everything that's happened since. The idea of inflation was introduced to explain some oddities about the universe around us. No matter which direction you look, on a large scale, everything's the same. You get the same number of galaxies, and the universe is at the same temperature. It seems like a cosmic coincidence. What you might expect is a universe that's far lumpier. The expansion introduced by inflation means that any lumpiness would be smoothed away. But until last month, we had no direct evidence that inflation took place at all. One of the leaders of the experiment that may have discovered the signature of cosmic inflation is Klempreich. Now, to look for this signal, you have to go, of all places, to the South Pole. So here's your Antarctic telescope, and BICEP 2 is actually in this dish here.
Yeah, in this kind of conical-shaped shield is the BICEP 2 telescope itself.
And why Antarctica?
So we go to Antarctica because the atmosphere there is fantastically dry. Now, this is very counterintuitive.
Because this is water that you're sitting
When you get off the plane, you're standing on 2 miles thick of ice, 10,000 feet of ice, and they tell you it's a hyper desert. And what little moisture there is in the atmosphere is in the form of ice and not liquid water. Now, liquid water is a killer for these kind of observations because it basically renders the atmosphere opaque.
Right.
So essentially, we can look straight out into outer space without the atmosphere getting in the way.
Okay, and you're looking at the cosmic microwave background, the oldest light we can see. And here's an image of the whole sky in microwaves, and it's a picture of the universe as it was, 400,000 years or so after the Big Bang.
Right, so these blobs, these hot and cold spots, red and blue spots, are places where there's a little more matter and a little less matter. And these blobs actually evolved into the galaxy clusters and galaxies that we see in the universe today.
Now, what BICEP 2 has given us, or seems to have given us, is the first evidence for this, or first direct evidence for this inflation. So what is it in this light that gives you this signal?
So inflation was already a popular theory, but in some sense it was kind of made up to fit observational facts. But what it also did is it made an additional prediction which was not observed, which hadn't been observed.
And this is to do with gravitational waves, ripples in space.
Essentially ripples in space-time, right? So that was an additional prediction. So when you have a theory, which is a very nice theory, a lot of people like it, you want to find some prediction that it makes that you can additionally go and check.
Right.
And that's, so the detection of these gravitational waves has been called a smoking gun for inflation, right?
Right.
Now, what they do is they impose on the polarization pattern of the microwave background a small additional signature, a small degree of swirliness, as it were.
So let's have a look. So this is the patch of sky. This is the BICEP 2 result with that swirliness that we were talking about. So these little arrows are the polarization signal.
Right. But here we've subtracted out the expected part, as it were.
Right.
And we're left with the so-called B mode, right, which is the swirliness of the pattern. Now, only gravitational waves, crucially, only gravitational waves can make the swirly part of the pattern.
And so it's the detection of this swirliness is the signature of that inflationary moment.
It's the signature of gravity waves, and the only plausible source for such strong, relatively strong gravitational waves is the inflationary theory. The competing theories don't predict.
So that's why this is such an exciting result. I think you were surprised by the signal, were you? Not that necessarily that it was there, but it was stronger than some people thought.
Yeah, so it's perhaps about as strong as was originally expected from the simplest inflationary theories, the ones that were formulated back in the 80s. Since then, more sophisticated theories have tended to predict lower levels. So this week's result was quite a surprise.
There must be personal satisfaction in this. I mean, people have been talking, it's way too early to talk about this, but people have been talking about Nobel Prizes and speculating and so on. Do you wander around the lab at late at night thinking, well, maybe this is it?
Well, it's only been a week,
Right.
but before that, before that we were just very focused on doing the most careful possible job that we could in the data analysis and just really being as sure as we possibly could be. It's very, very nerve-wracking actually to be sitting on something like this.
Yeah.
Quite stressful.
All right, well, we'll let you get back to it.
All right,
Thanks a lot.
Thank you very much.
Now back to Mars, and a mission that's being planned to take our exploration of the planet to a whole new level. The European Space Agency's ExoMars mission is aiming to be the first rover to directly search for life on the red planet. It will be equipped with a drill that will let it dig 2 meters below the Martian surface to a level protected from deadly solar radiation. If all goes to plan, it will be travelling to Mars in 2018.
I'm currently standing on what appears to be a patch of the red planet right here on Earth. This is the Mars Yard, built by Airbus to test the ExoMars rover and put it through its paces. Now, that's really necessary because ExoMars is going to go to a very alien environment. I've got Abby Hutty here, who is a structural engineer on the ExoMars project. So what are the challenges that ExoMars will face on the real Martian surface?
One of the first things that we've got to consider is that Mars is really very cold. So we've got nighttime temperatures that go down to minus 125 degrees Celsius.
That's brisk.
Yeah, a little bit chilly. And then during the day, it might not even get much warmer than minus 85. So you're going all the way between those two. And materials, as we know, expand and contract as they go through the different temperatures. And that's especially a problem where you've got structures that might be made of more than one different type of material, because where those two materials meet, they actually just tear themselves apart from each other.
I guess radiation is a problem too.
Well, yes, we've only got 1% of the atmosphere on Mars to what we have on Earth. So down on the Martian surface, you're receiving a lot more of that radiation dose. And that can be really damaging for your electronics and also for optical devices, like lenses can blacken with that radiation dose, and that can obviously have a huge impact on how far you can see or your sensors that require those optics.
So this is a prototype called Brian.
Yes.
So one of a series of prototypes. And looking at it, the wheels are a bit freaky. How do these work?
Well, we've actually had to develop these specifically for the Mars project because we can't take rubber tyres with us. Rubber is an organic molecule.
Yes, and you're looking for signs of life.
Absolutely. So we've got very strict regulations in place to make sure that we don't take anything with us that could be in any way confused for an organic molecule. So we've developed these wheels. They're entirely metallic, but you've also got to retain the flexibility of the wheel
That you'd get from rubber.
So we've got these very thin wafers of metal that actually are still flexible because they're so thin.
But how do you navigate across the Martian surface?
Well, that's one of the really big developments with ExoMars, and that's one of the reasons that we've got this Mars yard here. Because you've got such a long distance to Mars, it means you've actually got a 22-minute delay between sending your signal and it being received. So all of our rovers are going to be able to actually autonomously navigate around the surface. We've got 2 cameras at the top of the mast so that we can see in 3D. It can build up a map of how big the obstacles are and where they are in front of it. And then it can actually classify the different areas into, this is too big a rock, I can't climb over this, or this is a safe flat bit, this is good to climb over. And then it can pick its own path through that map.
Well, I can't wait till ExoMars gets to Mars. And thank you so much for sharing this with us.
Absolutely, it's been a pleasure.
Thank you. Now for that special treat we mentioned earlier. The team behind the high-rise camera that showed us the amazing images earlier in the programme are giving you the opportunity to take control and select the location for the next image of Mars.
It's a spectacular opportunity, and what we need is a scientific justification for your choice. So it could be an unusual formation, some strange colours, or maybe a famous place that you'd like to see for the first time with high-rise resolution. To take part, you can go to our website and tell us where you think the camera should be pointed. We'll close the entries on the 27th of April and we'll announce the winner in next month's programme.
It's a fantastic opportunity, so please do enter.
Well, we can't leave you without showing one last image from the Martian surface, and here it is.
This is an image taken by the Curiosity rover on the 31st of January. And rising high in the Martian sky is a fabulous evening star.
But that's no star, that's Earth, and I find it wonderful and humbling that we can see ourselves in the sky of an alien world.
It is a fantastic image. But that's it for this programme. Next month we'll be coming from the Brecon Beacons Astro Camp, where we'll be looking deep into space.
And you'll also have the chance to discover your very own asteroid as part of a real scientific search for near-Earth asteroids.
So, until then, get outside and get looking up.
Good night.
And The Sky at Night, How to Read the Solar System BBC book is available now. Spending time with a pop queen next this evening, definitely Dusty in just a moment.
On Earth.
That's fantastic. There's so much detail there.
We'll be giving one of you the chance to capture your very own photograph of Mars by taking control of the most powerful camera in Martian orbit.
And away from Mars, could this be the scientific discovery of the century?
But first, our journey to Mars begins above the Red Planet. It's astonishing what discoveries have been made without even landing on the surface.
Although we're used to thinking of Mars as a dry and dusty red desert, it's actually an amazingly varied and even a dynamic place. The HiRISE camera on NASA's Mars Reconnaissance Orbiter allows us to see the planet in exquisite detail. It reveals a series of extraordinary landscapes, from these vast fields of ice sculpted into varied and wonderful forms,
to shifting seas of sand dunes, their shady sides covered in frost.
There are areas covered in polygons where ice has thawed and cracked, creating these almost leaf-like structures.
And impact craters that help tell us the age of the surface of the planet.
And the HiRISE camera has revealed that this dynamic world can also change, almost in front of our eyes.
This is an image of spring arriving at the polar ice caps on Mars.
Mars is tilted on its axis, just like the Earth, and so it too has seasons. What you can see here in this sort of brain-like image is the ground emerging through the ice as it begins to thaw.
But this is actually frozen water and frozen carbon dioxide, otherwise known as dry ice.
Mars's atmosphere is so thin that it can't sustain liquid water on its surface in most circumstances. But have a look at these images from near the Martian equator. There seems to be something flowing down this slope.
Now this is quite controversial because there's debate as to what it is. Some people think water, and some people think it's salt water, which is actually fluid at a much lower temperature.
Other people think it's just carbon dioxide or maybe some dust rolling down the slope. If not though, this could be the first images to show liquid moving on the Martian surface.
Now the Martian atmosphere, over 3.5 billion years ago, it was very different. This history has been uncovered by a succession of rovers that have travelled to Mars as our surrogate explorers. In 2004, 2 rovers, Spirit and Opportunity, arrived on the planet. They were designed to survive for 90 days, but Opportunity is still going strong, 10 years later. And then in 2012, the much larger Curiosity rover arrived. In just a single decade, these missions have transformed our understanding of Mars by allowing us to read the secrets contained within its rocks. Geologist Ian Stewart has been investigating how the rocks on Mars have allowed us to search for signs of ancient water and recreate the planet's astonishing past.
Inside here is something really precious. That is a slice of another planet. This tiny rock is a bit of a meteorite which fell in Oman in the desert in 1990.
This month, there's a majestic sight in our night skies. Mars is the closest and brightest it's been for many years.
Mars captures the imagination like no other planet. So come with us and let us take you to this amazing world. Let's journey to Mars. We're in Stevenage, where Airbus has built a small slice of Mars here on Earth to test out prototypes for Europe's ExoMars rover.
And coming up, geologist Ian Stewart will reveal how these rocks help unlock the secrets of Mars.
So this really is evidence that through here, in the past, once flowed a mighty river.
Pete Lawrence will be showing us the great things we can see on Mars from right here.
It might be incredibly thin, but it doesn't mean there's no weather there, as we can see in this image. This spiral is a dust devil, 1/2 mile high, a huge tornado in the Martian atmosphere.
Now this is one of my favourite images. This is a uniquely Martian scene. This is the result of blocks of dry ice skidding down a slope, almost as if they were skiing.
Now we use dry ice here on Earth at room temperature to create a nice atmospheric smoky scenes. But on Mars, the atmosphere is at minus 150 degrees C, and so the dry ice stays frozen.
So what we're seeing here is something that couldn't happen on Earth. Mars is a funny planet. Sometimes it looks so Earth-like, and sometimes it does something like this that's uniquely Martian.
A little later, we'll be giving you an exciting opportunity to take control of the HiRISE camera and get your very own image of Mars.
Thanks to HiRISE and the other orbiting cameras, we've been able to explore the Mars of today. But what's really exciting is trying to understand the Mars of the past.
Today, the red planet is a hostile environment for life. But it now seems